So today we're doing Neat Code Zero to Hero. We're reviving it. Um, Today we're just reviving. We're doing a pretty classic problem. We're doing two sum. So you have an array or a list of numbers that are sorted in a non-decreasing order, so it's increasing from left to right. It returns the indices of two numbers, index one and two, such that they add up to a target. And index one is less than index two. Note that index one and index two cannot be equal, so you can't use the same indice twice. And there's exactly one valid solution each time. So, and then the memory constraints. You have O of one additional space. Okay. So let's look at their examples. So example one, we have a list of one, two, three, four, five, and we have a target of three. And we see that the output of the two indices are one and two, the target. So not zero and one. So I'm gonna keep that in mind. Constraints. Sure. Okay, okay. So when first looking at this problem, I thought of the brute force solution, which is to have to traverse a list with two while loops, one of the first indice, and then index two starting one after, and then just traverse like that, which is a n squared solution. Um, I solved it here, so you have index one, um, and then we have um, index two starting one after, so zero and one. So while index one is less than the length of the list of numbers, we traverse it. And then same thing with index two. If the combined sum of the two indices equals a target, then we return the two indices, and then we iterate through index two. We iterate index one after this inner while loop, and then we reset index two to one after index one. So this is an n squared solution. It works, but is it the best solution? Probably not. The next thought I had was to use a binary search tree. Because the list is sorted, um, we can use a binary search tree to do the same thing. So we have left to right, um, the same idea, right? I plus one, for in the range of the numbers. For the length of numbers, we have a temporary, which is the target minus the current value of the indice. You, if left is less than or equal to right, then we do the mid. It's the same idea. It's just a binary search tree. Like you're halving it here. You're going into the mid. That's the same idea you go through. I believe this is a log n solution. I think or n log n. Let's see. Binary search tree run time. I think it's a log n. Let's see. Yeah, that's a log n. All right. So let's see the solutions they proposed. So okay, so they had two pointers, binary search tree, and then they had a hash map. Oh, okay, hash map. So okay, yeah, yeah. No, it's n log n. Okay. Alright. Means this is a problem I've already solved before in the past, so it's a little easier. But we'll continue going back and resolving all the problems, and we'll hopefully do some new ones later this week.